Okay, we're going to be looking at a question, and in this one we're going to be solving quadratic equations. We'll semi-relate this to a graph, but we're going to use some basic math skills to solve questions dealing with the world's population. Okay, so this is a very crude estimate of the world's average growth in the year 2000. This formula here, that's what I was working with. Okay, so in the year 2000, X represents our years, 1 year at a time. When X is 0, that is when we're in the year 2000. Okay, this equation is kind of representing growth rate. Now, growth rate is not usually represented by quadratic equations, and we'll get into the types of equations it is represented with later, but this is a crude estimate, and it helps us with how to use them. So, our very first question is, what is the world's population in 2000? Okay, so what's the world's population in the year 2000? Well, that's when our X value is equal to what? 0. So what we're going to be doing is we're going to be plugging in the value of 0 into this equation. So in fairness now, population, when we write this in our function notation, would say P at 0, because we're taking X and replacing it at 0, is equal to 0.001 times 0 squared plus 0.108 times 0 plus 6.08. Our first term here, 0 squared is times 0.001, still 0. 0.108 times 0 plus 6.08. What do we get? 6.08. And these measurements, though I didn't write it, are all in billions. Okay? So, well, that means there are 6.08 billion people in the year 2000. Now, that is actually extremely accurate. That is pretty much what the world's population was at that time. Okay. Next, what we're going to try to do is, now I know that's in the past for us, but we had to use old stats to kind of come up with this. We're going to estimate what the world's population is in maybe the year 2010. Okay. So 2010. How do we go about solving what number to put in? What value will we put in for X? Why will we put the value of 10 in? That's right. Because 10 years have passed since the year 2000, think of it like we need to add 10 to this value of 0. Okay? So the next value we're going to be plugging in, and we'll do this one in red, we're going to be looking at the population 10 years down the road. And now this is a little off this from what the actual population is, but this is just an estimate like we said. We have 0.001. We're going to replace X with the value of 10. 108. 10 plus 6.08. Okay. We're going to plug this in. This becomes 0.001 times 100. This value, when we multiply by 10, is actually just going to become a 1.08 plus 6.08. We multiply this by 100. This decimal is going to move over 2. So we have 0.1 plus 1.08 plus 6.08. We're going to add these values together, and it's going to give us 7.26. Is that right? Yes, 7.26, and this is in billions. Okay. Now, this is a little off because the world's population is not 7.26 billion 10 years down the road. In 2010, anyone have any idea what it is? 6.8. I think it is. I think it is something like 6.8 at that time. Eventually, I think it's in the year 2012, the world passed 7 billion. Okay. 7 billion. So this was a little too generous in its estimations. But anyways, the idea here is we need to get used to how these quadratics are used to model situations and what values to put in. So with that being said, let's go about trying to make an estimate now. When will the world's population be 10 billion people? Okay? So, what I'm going to do is I'm going to make a quick graph here. It's just a rough sketch again. And we're going to take some of the information from our equation. Now, first off, we're in standard form in this equation, correct? We don't know, because the population is constantly growing at a faster rate. Okay? So let's try to estimate. This is how we're going to figure this out. So this is considered the C value in standard form. The C value represents what on a graph? The y, okay? So in other words, our y-intercept of this is at 6.08. Our a value is positive, right? And what we noticed is that at the value of 10, okay, that was at 0. At a value of 10, we were at 7.26, so somewhere here-ish. So it looks like our quadratic is growing, right? And we know quadratics make a parabola shape, so it's probably growing at an increasing rate, okay? Now, we need to get to a value of 10, okay? Now, we have to keep two things in mind. First of all, it took us 10 years to grow a little over or a little less than 1.2 billion, okay? But we are increasing at a faster rate. So it probably won't take another 10 years to increase 1.2. It'll probably increase faster. So what we're going to do is we're going to guesstimate here. We're not going to get an exact value. I want you to give us a range between what years what would be at 10 billion. What would you guys like to be as our first value to estimate?
Try 15.
15 is probably a great estimate number. Okay, so let's go with the x equals 15. What year would that be in? Yeah, according to our model, that would be in the year 2015. So let's use that value to go through this. The population, when we're at the value of 15, is equal to 0.00115 squared. If anyone has a calculator and can do this, it'd be very, very helpful. Okay. Do we have one there? How we do it? 7.925. Okay, so we're just a little under 8. So 15 is a great estimate for 8, but it's not quite where we need to go. Okay? What else would you guys like to try?
2018.
2018? I think we might want to move up a little faster than that.
2020.
Let's try 2020. Okay? Most of your calculators, you should be able to type this in one row, and then pushing enter, you should be able to get an answer right away. So, after quite a bit of trials, okay, at 15 we were at 7, 20 we went up to 8, so we decided to jump ahead. 40 we were over 12, and 36 took us to 11. 30 was too high, so we jumped down 29, 28. And between those 2 years in our model, between 2028 and 2029, our world's population will have crossed 10 billion. But that is in this model. That doesn't mean actually in real life. Okay, but that would be the idea of solving a question like that. It would be very difficult to use our types of estimations. So we'll have to estimate by trying different